So in this lecture capture video, we'll be talking about chapter 6, which one important topic involved in chapter 6. It was called limiting reactants. As it states here, the limiting reactant is the reactant that reacts completely and is therefore not present when the reaction is done. Okay, so the reactants always show up on the left-hand side. So normally we have two actual starting materials that we start off with called reactants. Once one of those materials is completely used up, then the reaction must stop, because without it, you can't keep making more of your products. Since the limiting reactant reacts completely, its amount determines the amount of product that can therefore be formed. So that's the important concept about limiting reactants. So illustrating right here, for example, you have here as two reactants. You have here the iron solid, okay, and you have here copper 2 chloride aqueous solution. So that's the blue stuff here. The iron is represented by the actual piece of nail here, okay. So notice this, the blue is done because of the copper, okay, present in the solution. Okay, so when you waste some time, you go over to the actual beaker on the right hand side and notice what happens here. Now all of a sudden the solution used to be blue, now it's become colorless. Okay, and notice here too, you see all this fuzzy looking thing that's growing here. Something actually started to grow onto it. So this is your iron here in the nails, but something started to come out of solution here, started to attack it. What started attacking here was this, is the solution stopped turning blue, which contained all this copper ion, but because the iron was losing its electrons to the copper, it became copper solid. So the actual limit to the reaction here was the amount of copper that was present in the solution, not the iron. So you can see here that once all of the copper was actually formed as a product, the whole reaction had to stop. So that would be an example of a limiting reactant. Now the excess would be considered what we know as something left over. So if the limiting reactant gets all consumed, then we have something called the excess reactant, which could be asked, which means what is therefore left over. In this case, it would be some iron. Okay. Now, of course, illustrating here with this car example here. So if you want to make a solar car, you need is a frame, a solar cell, a motor, and 4 wheels. Very important, you need 4 wheels here. So these are the 4 different items you need to make one model solar car. Okay. So you have the following. You have here 4 of these frames. You have here 5 of these extra solar cells. You have 6 motors, and you have here a total of 12 of these wheels. So the question that's asked is, what is the limiting factor here? Like, so how many of these solar cars can we build? Okay, so looking at something like this, very abstract in our macroscopic picture, we can simply just figure out how many of these solar cars can we put together. Whatever pieces are left over, okay, those will be considered the excess. Whatever was, of course, used, that was the reactant. At some point, we got to stop making solar cars. So in this case here, the wheel is the limiting part because it would be completely used up. Okay, so when you have 12 here, okay, we're going to make 3 cars, 3 sets of cars. The next wheel, of course, would be the frames, because when you have 4 frames here, but when you have, of course, is a total of 1 car, 2, 3, because each of these cars needs 4 wheels. So of all these items here that we have, between either the actual the covering of the car, the solar panel itself, the motor, or the wheels, what we run out first, of course, is the wheels. Okay. So everything else, though, is considered excess. This is limiting. So that's what stops us from making more of the solar cars. So how exactly does it work out? Therefore, as you see here, we have 1, 2, 3 cars built. We have left over as excess will be 2 solar panels, 3 motors, and 1 of the car's coverings here. So again, so how does this therefore relate to in terms of a chemical reaction? Well, using the fact that we have these chemical reactions here like we saw before, when we balance things, it's kind of important here as well. So questions we have, for example, here is something here has to eventually be consumed completely for the reaction to stop producing, in this case, something called carbon dioxide. So if we look here, for example, here we have carbon plus oxygen gas that when it gets heated up makes carbon dioxide gas. So let's see here. I have here 4 of the different 4 carbon atoms. I have here 1, 2, 3, 4, 5, 6 O2 gas molecules, a total of 12 oxygen atoms. Okay, that when they rearrange themselves upon heating, okay, these guys right here will rearrange themselves and going to make carbon dioxide. So looking at here, how many carbon dioxide molecules do we make? Well, we need CO2. So we need 1 carbon atom and 2 oxygen atom. That makes CO2. So 1 carbon one oxygen molecule makes a CO2. So we have here 1, 2, 3, 4. Okay, but now at this point we have something left over. So we have here 1, 2 oxygen molecules left over. That's unreacted. That's what we consider. Therefore, we know now that the oxygen gas is considered to be the excess reactant, which almost most of the time is considered that because why? It's really found in the atmosphere. It's in air. The carbon is what's limiting. The carbon, once we run out of carbon, we no longer keep making carbon dioxide. Okay, and again, this is a great way to actually see this stuff. But of course, and when we're in the lab when we're doing this, we can't actually just see these things. Instead, we have to quantify. We have to measure them. So that's what we're gonna figure out next: how to actually quantify this. Okay, at a molecular level. Okay, just like seen before. This is the reaction for now hydrogen to make water. If you notice here, you have here your hydrogen molecules in the white, the oxygen molecules on the red. Hey, to get together upon heating, you make H2O. And notice here, what left over is oxygen. So once again, oxygen is considered our excess reactant, but the hydrogen is what's limiting. Once we use all the hydrogens up, we gotta stop making water molecules. Okay. So again, the idea here now is to quantify and determine what is limiting reactant, what is the excess reactant, how much of an actual product was actually produced. Okay, so you can actually have two types. You can have one where you can make a lot more than you really think you should have. It's called theoretical. But then you actually have the actual amount that actually is going to be made. Because why? Once that reactant is used up, you no longer keep making products. So the way we do it is this. One question we ask all the time is which one is the limiting reactant? And one way is to quantify this. Here's one way of doing it. We're simply looking at a certain amount of molecules given of oxygen and hydrogen to start off. Okay. We also need the following. We need the following balanced chemical reaction, which is another crucial part in figuring out which is limiting, which is the excess, how much is actually a product that we produce, and so on and so much more for this concept. So here it seems like we started off with 3 molecules of oxygen gas, and we started with 8 molecules of hydrogen gas. Okay, the idea is we want to make a comparison. That's very important. You cannot compare the molecules of oxygen to the molecules of hydrogen, but they're not the same things. Okay, so in this case, I always say this: you always want to compare an apple to an apple, an orange to an orange. Never an apple to an orange, even though they belong to the same family of a fruit. Those type of fruits are still different. So you want to do is make comparisons. So here we go. So this is what we're learning right now about converting between reactants or products using a balanced chemical reaction called their actual coefficients. So it's calling stoichiometry. We use numbers in front of here now in terms of molecules, atoms, or in our case in chemistry when we count things as a mole. Okay, so we can read it as there's 2 molecules of hydrogen gas that are needed for every 1 molecule of oxygen gas. Then when you heat that up, you make 2 molecules of water gas. Now again, using the multiple ratio constant from before, you can simply drop the molecule wording and replace it all with moles. So in that case, I have here 2 moles of hydrogen gas plus 1 mole of oxygen gas will react with and make 2 moles of water vapor. So coming back here, we simply do is set up a conversion because again we want to compare the same compounds, the same elements or the same compounds. So in this case, let's just see what happens when we compare it to the same formation of water. How much water can be made if you have 3 molecules of oxygen, and how much water can be made if you have 8 molecules of hydrogen gas. Here we go. So you have your 3 molecules of oxygen gas. Keep track of units. So notice this. The one right here, this is the multiple ratio. So we're looking between the ratio relationship between oxygen gas and that of water. So we're looking between this one and this one. The way we do that is using the balanced reaction. Well, we see here that we have 1 molecule of oxygen gas makes 2 molecules of water vapor. So there we go. So downstairs then, I have molecules of oxygen upstairs. Downstairs should be molecules of oxygen. Upstairs is what I need now, which is molecules of water. Now the ratio is how many do I need? Well, it comes from the balanced chemical reaction. That's the coefficient. So looking at this, between water and oxygen, we have a ratio that's 2 molecules of water over every 1 oxygen oxygen molecule will be needed for this reaction. So it's 2 over 1. Molecules of oxygen cancel out. Now I have 3 times 2 is what? 6 molecules of water. It gets produced. All right, from 3 molecules of oxygen. That's fine. Again, we can't compare this to oxygen or this to hydrogen because they're not the same thing. So let's look at this one. 8 molecules of hydrogen. Okay. So this time I'm looking at the relationship between going from hydrogen now to the formation of water. So to do that, we look at stoichiometry. There is 2 molecules of hydrogen and 2 molecules of water to be produced. So again, keep track of units. Molecules of hydrogen upstairs, molecules of hydrogen downstairs. Upstairs, therefore, is what you need, molecules of water. How much? Again, this comes from the mole to mole ratio from the balanced chemical reaction. There's 2 molecules of hydrogen can be produced over 2 molecules of hydrogen. So it's 2 over 2 the ratio. Molecule hydrogen cancel out. 8 times 2 is 16. Divided by 2 is what? 8. 8 molecules of water. So now looking at this now you can make a comparison. So I have molecules of water, but they all came from the following. This 6 moles of molecule gets produced from 3 molecules of oxygen. These 8 molecules of water gets produced from the 8 molecules of hydrogen gas. The question is, which is limiting? Well, in this case, it all depends on how much you can actually make. Means not the amount total you can make. It's not the maximum or total amount. It's how much you get up to. So in this case, there's 2 ways. You could actually make 6 molecules of water or 8 molecules of water. But in reality, though, okay, you can only make a certain amount. So the 8 molecules of water is just way too much. So theoretically, you can make up to 8 molecules of water. But in reality, you're not going to end up with all 8. So the answer comes from this. It's the lower value. So here, I can only make up to 6 molecules of water, and that's when the reaction has to stop. Well, where exactly did the 6 molecules of water come from? Well, it came from the reactant of oxygen, the gas. How many? 3. So in this case, we end up using all the 3 molecules of oxygen gas to make all 6 molecules of water. Okay. In this case, we know we have here 8 molecules of water theoretically, okay, that came from the 8 molecules of hydrogen as the reactant. We don't have all this. We can't really make all this. We stop with 6. Therefore, to answer this question, the limiting reactant, which determines how much of this product water can be made, is oxygen. And again, it's something that happens. It's normally oxygen is the excess. In this case, it's not. It's the limiting reactant. In this case, the hydrogen is what's going to be excess. So there is still hydrogen, left over, even though you consume all of 3 molecules of oxygen. So the question is, one question can be asked is, how much of this hydrogen, of these 8 molecules of hydrogen gas, was actually consumed? But you still use some of this to make all this. So there must be something that was used to make this amount of water. And of course, the other question can be asked is, how much actually was how much is actually left over.